We're now going to do an example where we're going to maximize the profit that a tour company makes. So basically they offer the following rates for their tour. It's $200 per person if 50 people sign up for the tour, and that's the minimum number of people that can go on the tour. The maximum number of people is 80 people. Now if they have more than 50 people, they get a reduction on the price. So for each additional person up to a maximum of 80 people, the rate for each person is decreased by $2. Okay. Now to run the tour, there's a fixed cost of $6,000 plus $32 per person. So basically this wants to know how many people does it take to maximize the profit that they would make. So first of all, it's important to realize that the profit that you make is the revenue that you bring in, the money that you bring in, minus the cost. So up here we're talking about the revenue, how much money they'll make, but then you have, this is how much money they spend to do the tour. So the difference between that is the profit, and we're going to be maximizing that. So what we need to do is find an expression for the revenue and an expression for the cost. And to do this, we're going to let x equal the number of people on the tour, right? And notice here, the minimum is 50, and the maximum is 80. So this is the range. Okay, this is the interval that we're going to be maximizing this over. And the revenue here, revenue is just the price per person times the number of people. Right? That's what revenue is. And so what is the price? Well, they got to have at least 50 people, and then each additional person, they're going to reduce the price by $2. So it's $200 per person, but each additional person, they reduce the price by $2. So it's the price per person is $200, but you're going to subtract $2 for every person in addition to 50. So if x is the number of people, then I got like x minus 50. So if I have 55 people and I plug it in here, then I would get 55 minus 50 would give me 5 people, and it's $2 for every person in addition to 50. So 2 times 5 would be 10, and so 200 minus 10 would be 190. Right? So if they had 55 people, each person would pay 190. And so this would be an expression for the price. It's going to reduce for every additional person more than 50, which will be x minus 50. You're going to take $2 off that $200 price. And so my revenue here is just going to be, I could reduce this to 200 minus 2x, and this would be minus 100. So this would be like 300 minus 2x. So that would be my price. And so the revenue here is going to be 300 minus 2x times the number of people. So it's the price, this is the price times the number of people, and that would be x. So the revenue is the price times the number of people, and so that's an expression for my revenue. So an expression for my cost is just, there's that $6,000 fixed cost plus $32 per person. So it's just going to be a linear function there. And so my profit is going to be the revenue minus the cost. So it's going to be the 300 minus 2x times x minus 6,000 plus 32x. So this is an expression for the profit, and this is what I'm going to be maximizing. So let's see if I can simplify this. Distributing that x would give me 300x minus 2x squared. Distributing the negative sign gives me negative 6,000 minus 32x. So I could combine these here, and I'll maybe write it like a quadratic equation. So it would be negative 2x, and then combining these would give me negative 268. Oops, that would be plus 268x, because that's positive, that's negative, and then I'd have a minus 6,000. And so this is my profit formula. Now that's a quadratic equation that it has a negative leading coefficient, so it's open downward. It will have a maximum value. And so we could use the opposite of b over 2a, or we could use calculus here. If I use calculus, I would get dp over dx, and that would be negative 4x plus 268, right? And if I set that equal to 0, negative 4x plus 268 equals 0, this would be negative 4x is equal to negative 268. Divide both sides by negative 4, and my x would equal, you know what? My calculator's on the other side of the room. Let me go get it. Okay, so that'd be 268 divided by 4, and I get 67. So 67 people are going to maximize, and that will be a maximum. I could check that by taking the second derivative, right? D squared p over dx squared. And by taking the second derivative, I just get negative 4, which is always negative. So this is concave down, which it is. It's an upside down parabola. And so that's a max, right? So this is going to maximize the profit. Now you could check the endpoints of this interval, right, if we wanted to. So let's go ahead and do that. And we're going to check those in the original function here, which is right here, and just make sure that they're not bigger. Okay, that's the other thing you'd want to do. So negative 2 times, and you know, we know they're not because you have a parabola, upside down parabola, but just I'll just go ahead and do it. I started squared plus 268 times 50 minus 6,000. Oops, so that's going to be 2, so we'll say x equals 50, and then f of 50 is 2,400. X equals 67, f of 67, and x equals 80, f of 80. So we can plug in the other one. 67 will give me the maximum profit, I think. And I get 2,978. And then if I put in 80, that's like 2,640. So that would be the maximum, even given the endpoints of our interval. Okay, so that's maximizing the profit.